Hello everyone, Sam here. Today I'll go through a practical guide on how to use the common SQL functions that you'll typically use. And I'll use the decoded event, excuse me, I'll use the decoded event logs table as an example for us here today. So first thing I'm going to do is I'm going to pick a contract, and I'm going to pick a contract that has JSON and arrays, so we can work we can show those functions. And so one contract that comes to mind is the element NFT marketplace. Now you can search for contracts labels on Etherscan by searching like element, and then you search it like so. And so searching like this gives you the list of contracts, and that's how I got this contract. Alright, so let's head over to one transaction. And because decoded event logs uses event logs, we are going to be decoding, or rather, we're going to be looking at the decoded events for this particular event, right? It is this contract address and in this particular event. So let's do that in Studio. So I'm gonna say where contract address is this. Let's copy that, and of course you would want to have a block timestamp filter. I'm just gonna filter by this month. And I already know the things that I want, so the things that are important to me would be transaction hash, event index. I guess we want timestamp as well. And let's see what else, right? Event name, that's another big one. And the main, I guess the main content of the decoded event logs table, the decoded log column itself. Now here's where we come to our sort of like the first function that we'll go through, which is JSON, right? The decoded log column is in JSON format, and so it looks like this. And I've talked about this before in a previous video, but if you want an easier way to like if there's nested JSON, like multiple levels of JSON, you can use this website like JSON, I guess codebeautifier.org, copy paste this into here, and it sorts out nicely for you. And so if you click on any key, it will tell you up here what is the route that you should be using, right? So in this case, let's say I want ERC20 token. If I want to get this value over here with this key, I just have to say decoded log and then ERC20 token, and then I'll get this value over here. And then same thing for fees, because fees is an array, then there's an extra array they need to do. I'll show that in the query in a bit. Okay, so anyways, because this is a straightforward JSON, you would just have to like if you want to get ERC20 token, you just have to do this notation. Oops. Okay. Decoded log ERC20 token. And you get the value, but it would have quotation marks. So let me just show you. Oh, it doesn't. Okay, cool. Yeah, it's as simple as that in terms of using JSON. So again, use this quotation, and then whatever the key or whatever the name of the key is here, put it here, and then you will have your the value, right? Usually I would cast it as a string, because I find that sometimes it does remain its quotation marks. So just cast it as string again to remove quotation marks just in case. And then you can rename your column. Let's say ERC20 token. So this would be like the currency address that someone is paying the NFT with. And I think what I'm interested here is mainly the amount and the fees. So I'm gonna go ahead and get the amount and fees. You can of course just copy paste, and then because this is an integer, I'm just gonna cast as int seal amount, right? Let's call it raw. And so yeah, basically that's JSON for you. And now we've come to arrays, right? You will know if it's an array if it's in these brackets. Another way to know is if you look at the event logs, there is the same brackets over here, right? Tuple and then this brackets. This just means the fees is an array, and so this is what you're seeing here, right? It's an array. So to get that array, there's two ways, right? One is, let me just query this first so you can see. But there's two ways. One is you tell the query itself, I want to get the first element in the array, and that's denoted by this way right here. And so you can see this first column here is just fees, right? And then fee 0 would be the first element in the array, which is like there's only one, right? Let me try to find if there's like more than one. Oh, there you go. So this transaction over here has two elements in the array, right? There's amount, recipient. This is the first element, and the second element is another amount and recipient. All right, and you can see that if we just did fee 0, we just get the first element. Now, usually we wouldn't rely on the element number because we don't know first of all, we don't know how many fees will there be in the array, right? There could be 1, it could be 2, it could be 3, and so how do you write this dynamically, right, to account for all cases? You can't, right? And so the next best thing we can do is to just flatten the array. And flattening just means pulling out all the possible elements into a nice into one row for each element, so that we will be able to get all of the possible fees in that array, right? And let's try to do that. So first of all, let me just rename this like fees array, right? And so this is our base table, and we want to separate out the fees portion so that we can flatten it. You can of course flatten the table here as well, like so, like lateral flatten, and then flatten in this same query, but we want to make it neat, and so we're going to use a CTE here. A few ways to use CTE. I like to use it as like a way to separate your queries. So in this case, this would be my base, right, so to speak, my base query, and then maybe I have another one called fees, right, just fees, where I'm selecting from base, and this would just be my fee CTE. So the way to flatten is, well, first you need the columns from your initial base. So I'm just going to use transaction hash, event index. That's what's important to me here, because then I'll use this information to join it with my base, right? Again, if you would like to have flatten in the base query, that is the same as well, right? That's totally fine. Alright, okay, let's see. So fees array, and then the notation for this is lateral flatten, and then input then will be what is the column that you want to flatten. So in this case it's called fees array. And there are a few outputs from flattening something, right? Flattening again, given how there's two elements here, we will get this in one row and this will be another row. Now I mainly only use two things after flattening. One is index and one is value. Index is the index of the element. In this case this will be 0 and this will be 1 after flattening, and then value is just the value of the element itself. And so if I were to run this query, oops, what error is this? With base as, fees as, transaction hash from base. Error line position to select. There's an extra thing here. Seems like something obvious I'm missing, an extra comma or something. Let's see if it runs if I remove this. Okay, it's not affected by that. With base as, fees as, select transaction hash, fees array. Oh, I forgot the word as. There you go. Okay, there we go. Alright, so where were we? Okay, so we're saying, so fees array is my it's my full array, right? Okay, this is an example with two elements, and you see that maybe it's better if I just filter for this transaction, and transaction hash is this. Okay. Alright, cool. So again, this array has two elements, and you see that after flattening, there are two rows because there's two elements, right? Index 0 being the first element, index 1 being the second element, and the value would be what that what's the value that has been, I guess, what's the element of the content that has been flattened, right? In this case, you can see this is the first part over here that goes to here, and then this is the second element that is derived from here, right? And so that's how you flatten, right? You've got your table name, and then this this notation here, lateral flatten input, and then you do this sign, and then the column that you want to flatten, an array, right? The array column that you want to flatten. And so what's the purpose of flattening? So by flattening, we can now do we can now query, or we can now get these values as one row, and so we don't have to always specify, fees array 0, fees array 1, fees array 2, right? Because there can be multiple, there can be, infinitely amount of fees. Well, practically no, but okay. So how do we get this amount out? Well, this is a JSON, and we know previously to get this value, we can just do this notation, value amount, right? And we would get the amount. In this case, it's a fee amount. raw, and then value recipient as fee recipient. And yeah, that's pretty much it. Right? Whenever there's JSON, just use this notation. And then because it's arrays, we're gonna flatten it. And let's see. So the final output is we have 2 rows for this one particular transaction and event index. And we have the nicely flattened out fee amount and fee recipients. Okay. So how do we make use of this? Now maybe you can say, I want to know what is the platform fee, or what is the royalty fees or creator fee, right? And you can do your research as to which address is the platform fee. But I've done my homework, and this is the address, which is the platform fee. The way to know is if you just look at a bunch of transactions and see what's the common recipient. Make sure that it's different NFTs, so to rule out that this is not the royalty recipient. And then I guess one sign is if I plug it on Etherscan, it is a multisig, so that's always a good sign. If you look at internal transactions, which is all the ETH sent to this address, you can see there's all elements, so highly likely this is the platform address, right? And then this would be then the royalty receiving address for the NFT transacted in this transaction. In this case, it looks like it's CyberV. Okay, so how do we do this? So the way I would do it is, I would say something like case when the recipient is this address, which I know to be the platform fee, then if it's this address, then the amount, else 0 ns platform fee amount, I guess platform fee raw, right? So what I'm doing is I am saying if for any row, if the recipient is the platform fee, get the amount. And so for this row, which is not the platform fee, it will just be 0, so that when I sum it later on, I would be able to put all this in one row. And I'll show you what I mean by that. Okay, let's continue here. When the fee recipient is not the platform fee, then again fee amount, L0 ns, I guess royalty fee. Alright, let's see. So we added 2 new columns, platform fee and royalty fee, like so. And now we're going to sum this together, right? So that we will get only one row for one transaction hash, where it is how much is the platform fee and how much is the royalty fee. I'm just going to add a underscore here so that when I sum, the column names won't be the same. So make a new CTE, call it fees aggregate, select from fees. Now because I'm gonna do a sum, I want an identifier in my transaction. In this case, it will be transaction hash and event index, right? Now why these two is because these two will be unique to my data here, right? Recall earlier when I grabbed the data from decoded event logs, there's only one row, right? There's only one row in the event logs denoting this is the sale and this is the fees, everything in the array, right? It's only when I flatten it became 2 row, and so we want to go back to the state where it's 1 row. so that we will be able to join it back to the decoded event logs. And so how I will do that is event index and then sum. What am I summing? I'm summing the platform fee, and I am summing the royalty fees. Call this as and then of course group by. You can just use group by all. Same thing as group by 1, 2, or group by transaction hash event index. There you go. We have one row with transaction hash, event index, and then the platform fees nicely in one row. And so how does this relate back to our initial query, right? So if we were to go back to select base, we can see that we've got stuff like currency address, sale amount, and this fees array, right? It's an array. We can't make use of it properly. And so if we were to use the fees, the data that we just got from fees aggregate, join it back to this row, we will then have one row with all the sale amount, the fees, and all the fees, right? So let's do that. So remember how I said this is the identifier that we will use to join it back to base, and so that's what we're gonna use. So select from base. I'll just do an inner join fees aggregate. Now you can do something like like on b dot transaction hash equals to f transaction hash, but because the column names are exactly the same, you can just use using here, like so. This is what it looks like, and what this gives me would then be one row where with all the base information like transaction hash, event index, timestamp, right, currency address, sale amount, and then fees array. We can disregard this column already and instead use our two new columns, platform fee raw and royalty fee raw, right, which are derived from the fees array. So you see how we extracted the fees from its array, flatten it, and then perform a sum, and then join it back to the base table. Yeah. Cool. Alright, so what else? Let's see. I guess window functions. Let's see, how do I include Windows functions here? I guess we can add a small price. Okay, let's do it. So first I want to know what does the prices table look like? Thing is this. Yep, okay. I have not queried the prices table in a while, so I forgot what it looks like. But I assume we would want WEF price. So let me just grab WEF's price. Okay, token address. So where token address equals to WEF, and our is April, 1st April. Okay, we want our decimals price. Alright, cool. Alright, cool. So what we're gonna do with window functions, I am thinking row number. So like, what if you want to get the latest price, like the closing price for each day, right? And so if you were to do if you just run this query by itself, you would get all the prices starting from midnight all the way to 11 o'clock p.m. the same day, right? And so what if I want to get just the 11 p.m. price, right? And so how you would do that is you would use a window function. One of it is called row number. And the window function's notations look like this, right? Row number over, and then partition by is optional, and then order by, right? Essentially, row number just assigns a number for each row, and the I guess how it gives a number is determined by what you write in this parentheses over here. So row number over partition by, for example, we want to partition by, if we partition by the date, that means every time we hit a new date, we reset the number. And every time we hit, and of course partition by token address, because every time we hit a new token address, we want a new number. In this case though, I've already filtered out my date and token address to be these two, so it's not needed, but I will do it regardless, right? Just to show you something like this, token address, right? So I'm partitioning by the date. Every time it hits a new date, it makes a new number list. And the reason for that is because since we only want this date's last recorded price, we want our numbers to end here, right? We don't want it to continue like, on 2nd April, the number to continue. If it does, then we will be getting the number for 2nd April instead of 1st April. And so that's why we're partitioning by date, and the same argument goes for token address. And then order by our descending, or let's say ascending, and let's just call this as rn. And let's see what this runs. So we're creating a new column called rn that assigns a number that is numbered based on these conditions that we've specified. The first thing we specify is partition by. And then the thing that's I guess important is order by. So in this case, it's ordering by the hour ascending. So you can see how midnight gets 1, 1 a.m. gets 2, so on and so forth, and then 11 p.m. should get 24, right? And so if we want rn to be if we want to get the last value, there's two ways. One is we can say rn equals to 24, because we know 24 should be the last recorded price for the day, right? There you go. The other way is of course to then change the order to descending and change your rn to 1. Now I'm going to show you what that looks like without the qualify. Now if it's descending, your 11 p.m. is now have a value of 1, right? It starts from 1 when doing the row number function. And so when you do qualify rn equals to 1, you're saying I want the row number where the hour is in descending order, and so that's how you get the latest price per day. So that's, yeah. And why qualify instead of having or where? Qualify is for window function, so like row number, and then having is for just your regular aggregate sums, like sum, counts, right? And I think that's it. Hopefully this is helpful. Just a very quick practical guide on using the common SQL functions you see: JSON, arrays, joins, flattens. And yeah, thanks for watching. See you all next time.